Welcome to everybody's favourite subject, factorising, right? So we're going to do a quick review of the different types of factorising questions that you can get. We're going to start off with doing trinomials. Now, I coined this term myself just 5 minutes ago because I thought we've got trinomials with 3 terms. What are we going to call factorising questions with 2 terms? We're going to call them trinomials. Love it. Okay, so common factors first. Before you do anything in a factorising question, you have to try to take out common factors, and that's going to catch a lot of little mistakes that you make. Okay, so if we do that with this one, if we look for common factors, now remember, a common factor is a number that's going to go into this term and this term. So we're looking for something that's into 4x squared and into 12. Alright, so what's going to go into that 4 is, we take out our common factor, so x squared plus. Now, the point of a common factor is that if we factorise using it and then we multiply the bracket back out again, we get the original expression back. So what do we need to times 4 by to get to 12? We need to times by 3. Okay, so really important point here is that you should never really make a mistake with a factorising question, because you can just break the brackets and get back to the original question. So if we multiply this out, we'd have 4x squared plus 12. Okay, so you can check your own work, it's really good like that. If we look at this one, we don't have any common factors, as you'll see, but we do have a square number. This is a dead giveaway that it's difference of 2 squares. Okay, difference because it's take away in 2 squares. We've got a squared term here with x squared and a square number here. So as soon as you spot square numbers, right, so remember those, that's 4, 9, 16, 25 and so on, all the way up to 81, 100 and all that. As soon as you spot a square number, it's difference of 2 squares and there's no common factors. So common factors first, there are none, so it must be difference of 2 squares, and that's set up, remember, just like that. Okay, so we have common factor factorising, we have difference of 2 squares, and that's how we deal with a factorising question with 2 numbers in it, or a trinomial. Okay, so you're looking for common factors here, and then trying to factorise. Can't factorise this anymore. If we multiply it out, we get back to the original expression, so we know it's right. Look at this one, we can't do common factors, there are none, but we recognise that it's a square number and a difference, so it's difference of 2 squares, so that's how you set that up. Remember, square root of 81 is 9, we put a plus and a minus, doesn't matter the order, that could be a minus or a plus. Okay, you can switch that around, and an x in each bracket, so we can set those up. Those are really simple, but it's important that you can spot which one's which. Okay, right, so moving on to trinomials. So trinomials is when there's 3 terms. Right, welcome to the continuation of the factorising review. We're going to look at trinomials now, so that's expressions with 3 terms. So we've got x squareds, x's and numbers. See, x squareds, x and numbers. So that's a trinomial. Easy to spot in comparison to trinomials, which have 2 terms. So 1, 2, 3 or 2, right? So factorising trinomials, remember, is when we're looking at double brackets, wrong colour, looking at double brackets, and we're looking at factors of 18 that are going to give us -9 when we add them together. Now, how do we decide whether we're doing the magic x or whether we're going to try and just factorise it in our head? Well, I try and decide that because, or through that, this has got a coefficient, okay, we've got a number in front of the x squared, and this expression doesn't, okay? So we're going to use a magic x for that because this one's a bit harder. Right, we're going to need a little sort of structure to do it, but this one I think we can manage to do it in our head. Okay, so we know that each bracket is going to start with x, and to get the numbers that are going to go here, remember all we have to ask ourselves is what factors of positive 18 add together to give us -9. Now if I think about that, if I've got my factors of 18, I've got 1 and 18, I've got 2 and 9, I've got 3 and 6, but I'm getting -9. So both of those have to be negative to multiply to give us positive 18 and add to give us -9. So if I look through all my factors, it's like a little puzzle, then I'll see that -3 and -6, right? -6 times -3 gives us positive 18, and negative 6, add negative 3 gives us negative 9. So that is our answer for this one. And again, if you multiply this out, you will get back to this original expression. Okay, we get x squared minus 3x minus 6x, which gives us minus 9x, plus 18 at the end. Okay, so that one's a little bit easier because we don't have a coefficient, and we can just ask ourselves what factors of this number add remember, to give us that number. And those numbers can go in the brackets in any order we like. Okay. This one's a little bit different. We're going to use the magic X method for this one. Now remember, magic X, I'm going to do it underneath, like this. Magic X works like this. Okay, so we take the lead coefficient and the end number, and we multiply them together, and that gives us the number at the top. Then the middle number here goes at the bottom. Now I'm asking myself, what numbers multiply to give me minus 24 and also add together to give me 5? So if I think through all my factors of 24, and think through them all, 8 and 3 immediately jump out because they've got a difference of 5 between them. So if I think about 8 and 3 for a minute, and I think, okay, so one of those has got to be negative and one's positive, so they multiply to give us minus 24, because a positive and a negative are going to give us a negative when we times them. So which one's got to be negative to give us a negative 5? It's got to be this one, hasn't it? So let's just check that. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. So that's it. So we've solved a little puzzle. Now, the magic X method, the last thing you need to do is to divide by the 2. Now, where does the 2 come from? The 2 is the lead coefficient. That's the first number you see. The number in front of the x squared, you have to divide by that. Okay? Then what we're going to do is I'm going to stick to this colour. In fact, no, change it just in case we can't see right. And we're going to simplify our x down. Keep these numbers as they are, and we're going to simplify down the x, so that's going to be negative 4, 1, and that's going to remain at 3 and 2. Okay, so this is our simplified magic X that's going to let us write down our answer. Okay, so double brackets in. And the bottom number gives us the coefficient of the x, so it's going to be 1x, take away 4, and 2x plus 3. Now, I don't really like writing down 1x, okay, we don't really write that down, so if you want to write that down to start with and then rub it out, that's okay. Right, it's just to show you where that was coming from. So we've got x take away 4, 2x plus 3, and that is our final answer. That question that comes straight from this simplified magic X here. Okay, so remember, what you can do with this video is you can rewind it back and watch it as many times as you want. Alright, hopefully this should give you a little bit of an idea about the different types of factorising questions that you get. Okay, so remember, wind it back, use it for your revision, use it when you're doing your worksheets at home, and make sure that you can do that. And if you can't, then please see me one-to-one and we can have a chat about it. Okay, right, thanks very much guys.